You're listening to the N2K Space Network.
And now, a word from our sponsor, Zscaler, the leader in cloud security. Cyber attackers are using AI in creative ways to compromise users and breach organizations. In a security landscape where you must fight AI with AI, the best AI protection comes from having the best data. Zscaler has extended its zero-trust architecture with powerful AI engines that are trained and tuned by 500 trillion daily signals. Learn more about Zscaler Zero Trust Plus AI to prevent ransomware and AI attacks. Experience your world secured. Visit zscaler.com/zerotrustai.
I do say it a lot, but it really is an exciting time to be a space nerd. And we are not in a space marathon, nor are we in a space leisurely stroll on the beach. We are in the thick of a space race 2.0, my friends, or more accurately, 5.0, because we've now seen launch number 50 for commercial launch provider Rocket Lab.
T-minus 20 seconds to LOS egress. Go for deploy. Roger roll.
Today is June 21st, 2024. I'm Maria Varmazis, and this is T-minus. That's launch number 50 for Rocket Lab. Honeywell to acquire CAES. Starlab and Palantir make a deal. And our guest today is Michael Hurowitz, founder and CEO at WeatherStream. Happy Friday, everyone. It's just me today, so no Friday joke. I wouldn't dare. Alice is at the Spaceport America Cup today, and we'll have our update from her later on in today's briefing. Rocket Lab has successfully completed its 50th Electron mission, deploying 5 satellites for French IoT company CAES. This achievement is significant, as Rocket Lab reached 50 launches faster than any other commercially developed rocket, surpassing even SpaceX. The Electron rocket, which first launched in 2017, has become a key player in the small satellite market, providing frequent, tailored, and reliable access to orbit. The No Time to Lose mission, and Toulouse in this case is spelled like the city in France, lifted off from Rocket Lab Launch Complex 1 in Mahia, New Zealand, and deployed the satellites into a 635-kilometer orbit. This launch is part of a series of 5 dedicated missions for CAES, aimed at enhancing global IoT connectivity. The CAES constellation is designed to provide real-time data transmission and connectivity to remote locations, supporting applications like forest fire detection, water resource management, and logistics tracking. Rocket Lab's rapid achievement of 50 launches highlights its growing influence in the space industry. And CEO Peter Beck emphasized that this milestone showcases the company's ability to provide precise and valuable services to the small satellite community. Across its 50 missions, Rocket Lab has deployed 190 satellites for various customers, including NASA, the National Reconnaissance Office, and many commercial clients. Congratulations on your nifty 50, Rocket Lab. Honeywell is set to acquire CAES Systems for $1.9 billion, marking its third major deal just this year. CAES, which is a leader in aerospace and defense electronics, specializes in systems like antennas and communications networks critical for both military and space applications. CAES has significant expertise in developing resilient electronic systems that are crucial for space operations, and this includes contributions to satellite communications and space-based radar systems. And by acquiring CAES, Honeywell enhances its portfolio with advanced technologies that support major defense programs, such as Lockheed Martin's F-35, and it also fortifies its capabilities in the space sector. And this deal is expected to close in late 2024 and will bring additional automated facilities and 2,200 skilled employees to Honeywell, bolstering their aerospace and space operations and driving future growth. Starlab Space, the global joint venture between Voyager Space, Airbus, Mitsubishi Corporation, and MDA Space, has partnered with Palantir Technologies to enhance the operations of its commercial space station. Palantir's AI-driven software will optimize resource allocation, mission planning, and system performance. And this new collaboration aims to improve efficiency, reduce costs, and extend the lifespan of critical components, ensuring effective space station management. And yesterday, NASA, FEMA, and other agencies conducted a planetary defense exercise to test responses to a potential asteroid threat. And the exercise helped refine strategies and improve preparedness for such an unfortunate and rather scary event, ensuring effective collaboration and response. Now, I should note, no current asteroid threats exist, but planning and exercises are crucial for future readiness. And we have a few links for you in the show notes so you can learn more about this, both the release summary from this tabletop exercise, as well as a full play-by-play written up by Space Policy Online. Munich-based Mynaric, which produces optical communications terminals, has released their full year 2023 financials, saying last year they had a record backlog of 794 ordered units, compared to just, 256 in 2022. And they are also in the middle of a very busy 2024 to fulfill shipments of their Condor Mark III units to multiple customers. Mynaric expects that those orders for optical comms terminals will drive upward of 70 million euros of revenue for the company in fiscal year 2024. Now, no big deal, says JAXA, but we've been hit with a couple of cyber attacks over the last year. Oh, okay. According to a report in Nikkei, the Japanese Space Agency has been hit with multiple cyber attacks that are suspected to have originated from Chinese-affiliated hackers, and those hackers may have accessed employee personal data, proprietary information belonging to companies working with JAXA, as well as some level of classified documentation. However, JAXA says nothing related to Japanese national security or rocket or satellite operation was accessed. Overall, this latest spate of cyber attacks against JAXA are, and I quote, no great concern, according to Japanese Science Minister Masahiro Moriyama. Our congratulations to Colonel Phoenix Hauser, who recently took command of Space Delta 7, which is responsible for space intelligence, surveillance, and reconnaissance at Peterson Space Force Base. Space Delta 7 plays a key role in detecting and addressing adversary space capabilities, and we wish Colonel Hauser the best of luck in her new billet. And a noteworthy milestone for your consideration today from Look Up Space. The Space Situational Awareness Company says, according to their own count, we have now surpassed over 10,000 active satellites in orbit, with over 9,000 in low Earth orbit and over 6,000 just belonging specifically to, wanna guess? Starlink. And to close out our briefing today, here is our From the Field update from Day 3 of the Spaceport America Cup from T-Minus producer Alice Carruth.
So we're on Day 3 of launches here at Spaceport America for the 2024 Spaceport America Cup. The first launch took off at 7:42 this morning, and it was George Washington State University's 2-stage. We've already had a second 30-foot launch already this morning, and we're expecting a lot more. There's a lot of cloud cover today. Yesterday, it caused a huge delay, and the whole site was shut down at around 1 o'clock local time. So these students are very eager to get launches up on Friday, and I'll be bringing you a full report of the entire Spaceport America Cup and the winners on Monday's show.
Thank you for that update, Alice. And that wraps up our briefing for this Friday. If you've got some spare reading time this weekend, may I suggest taking a peek at our show notes? We've got links to all of the stories from today's show, plus, as mentioned, the full rundown of the asteroid threat tabletop exercise that NASA and federal partners just conducted. Hey, T-Minus crew, tune in tomorrow for T-Minus Deep Space, our show for extended interviews, special editions, and deep dives with some of the most influential professionals in the space industry. And tomorrow, we have former NASA astronaut Susan Kilrain talking about her new book, The Unlikely Astronaut. Check it out while you're cooling down from the summer heat, trying to keep your kids occupied now that school's out, or reminiscing about all the fun you had at DC Spaceball on Thursday. You don't want to miss it.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
Our guest for this Friday is Michael Hurowitz, founder and CEO at WeatherStream. And I asked Michael to tell me about how his company started.
The original research actually started back in the 2008, 2009 timeframe, and the whole idea was we see this sort of movement taking shape around miniaturizing spacecraft and making satellite platforms more available, lower cost, and the launch, especially with SpaceX sort of leading the way on low-cost launch and enabling the whole new era of commercial services that didn't maybe used to be possible because of the sort of cost structure of putting something in space. And then combining that with our team's research background, which goes back almost into the 1980s with our chief scientists working in this field of passive microwave remote sensing, which is something a lot of people have never heard of or really know what it is, but ultimately is sort of the most important satellite sensor that we have for improving our weather forecasts and kind of measuring the atmospheric state, temperature, humidity, clouds, and rain, and so forth, and helping bring that data into weather models. So for the physics-based models, microwave soundings has sort of risen to be one of the most important measurements. And then there's infrared soundings and a whole bunch of other data that are used all the way from ground-based sensors, weather balloons, aircraft measurements, other satellite sensors. There's a lot that goes in to producing a weather forecast, but microwave sounding has sort of risen to be this critical piece of the weather infrastructure. But at the same time, the historical programs are pushing $200 million for a single sensor. And so as a result of that, our current weather infrastructure is very exquisite and produces extremely high quality data, but we don't have data on the timescales that sort of relevant to the changes in weather. Weather can change in 5-10 minutes for severe storms. Things are happening very dynamically, very rapidly. And for a lot of these microwave systems, we're just not seeing sort of those dynamics. So our sort of kind of a convergence of that problem statement with this miniaturization effort and the core research area of developing these sensors. And so brought that all together and started developing very low-cost microwave sounders, sensors that can be built for under $1 million. And there's a lot of innovation that went into coming up with the hardware technology. But ultimately, we could have been a sensor company, but we thought, well, maybe there's a unique approach to use our sensor technology to build a data company. So that's sort of how we got started.
When we talk about data observation from space, weather and climate is often usually number one. So you're talking about really fast data collection. Well, I mean, is that am I understanding that correctly? Like what is the specific really unique application there?
Well, it's more driven by the sort of observation needs rather than the sensor technology, if that makes sense. So what we want to do in any system, if we're trying to be able to predict it, and weather and the environment is a very turbulent, very chaotic system, and we ultimately want to be able to measure it on the time and space scales that it's evolving at. So if weather patterns for especially severe weather events are evolving in the 10, 15-minute type of time frame, then that's how often we want to be sampling them. And then we also want to be sampling them spatially at sort of the scales of the features that we're trying to observe and predict. So it's really driven by the needs of the prediction system, right? And so with our current sensors, we're close on the spatial scales for a lot of things, but for especially like severe weather events, there's a lot of things that are sort of below the sensor resolution that you can't necessarily see with current systems, or you can't see all the details. And then for the temporal perspective is where we have the biggest gap, or 6 hours roughly is our average global revisit rate for microwave soundings. And that's between global governments collaborating. But weather obviously changes a lot more frequently than every 6 hours. So there's sort of this data gap to solve. And there's many, many studies out there showing that how sparse the data really is for weather observations, especially, there's places all over the world where we have very little to no infrastructure for this, ground-based weather radars, weather balloon sites, et cetera. There's just sort of data desert, if you will. But with $200 million a sensor, nobody's going to foot the bill for a $50 billion weather system. And so there's a number of problems, both technology and economical, that have to be solved to move the needle. It's not an easy thing to do.
No, not at all. You're fitting in that the lower cost sensor, much lower cost sensor, which is thanks to the innovation that you all have driven with what you have built. So what does the sort of system look like around that? Are we talking like a constellation, or what's there?
Weather is unique in that we don't actually need like a huge constellation. You see some of these communications programs need hundreds or thousands of satellites, and it's not that. To measure global weather in real time, you need somewhere between 30 and 100 satellites. It's not as if there's necessarily a one-size-fits-all. We're trying to sort of start with something that will address as much as possible, but recognizing there's no one sensor that's going to do everything, right? And so there's still a need to have different sensors doing different observations, and then on different time and space scales depending on the event type. So tropical cyclone's a great example, one of the most catastrophic type of weather events, one of the most difficult to predict. So we work pretty closely with a number of agencies that do work on tropical cyclone forecasting, and there's many, many different models, many different sensors, but ultimately they really struggle to predict the path of these storms because there's sometimes many hours between observations. You're trying to move military assets, civilian assets, working with our allies, embedded meteorologists out in the field trying to help make decisions on the ground, and they're all sort of relying on infrastructure to tell them what to do. And it's this huge collaboration going on internationally to try to solve these problems. And more data helps in it. Just having more frequent observations makes a huge difference in their ability to execute on that mission is one primary example.
Absolutely. And so we have more data, and then also the understanding of that data. You mentioned models, and obviously there are many different models, and some are more loved than others, I suppose. But I do hear machine learning get thrown around now and then. How does that apply here? Is that relevant? Is that something you all are looking at?
It's a key piece of the toolbox. AI and ML type of models are very powerful and have a lot of potential. And in a lot of ways, we're still starting to really figure out what the limitations might even be. But we, at least for what we know, I'm sure there are people who firmly disagree with me, but we believe that sort of a hybrid approach of using both physics and machine learning-based models is at least in the near term, going to be the key. Once the data observations are available that solve that sort of, maybe then the AI models could fully take over. But ultimately, the physics models are what we're using to generate the training data for the AI models. So without that, you sort of have a missing piece. And then we've been to many, many presentations. And our own team, we have 5 or 6 people on our team with PhDs in computer science who are all working on these type of models. We use them in many different ways internally for different parts of the process. So it's a key tool, and everyone is quickly adapting to use it, but they will improve dramatically when you have enough observations to improve the training, and then also to drive the models once they're built.
Yeah. So again, that data gathering, as you've been talking about, is so key. So, I mean, I guess timelines and sort of long-term vision here. So, what are you working on right now, and what is coming?
Sure. Well, let's see. So we're building our second generation mission now. So we have the next 2 satellites in production, which is really exciting to see it coming together. We're about ready to ship the next one. And our goal is to be launching somewhere between 6 and 12 per year going forward. That will basically, over 3 or 4 years, build up our system and then just maintain that. So we're anticipating conservatively about a 3-year lifetime for each spacecraft, but we can probably get closer to 5 over, as the designs continue to evolve. And then it's really on the commercialization side is where the longer path is of helping integrate this data into different industries, different processes. There's so much customization that's needed with weather for different use cases. And we're not really trying to do it all. We're more of a partnership-driven company. We're working with a lot of partners there's a lot of great companies that do analytics and modeling and downstream applications, and we want to partner with them. We want to help solve the data gaps, but not necessarily build all the applications. We're doing a little bit of application development, but we try to resist that.
Yeah, you want to specialize in what you know that you can do so well. I really respect that. So in terms of the end user, I mean, again, this is a commercial application. Are we thinking disaster response, insurance? Like, who are the primary users?
Well, there's a lot of great sort of independent research on like the market out there, but basically there's a few different segments. So sort of the weather forecasting market, There's the overall weather and climate information services market. And there's something like 20 different industry verticals that make use of this in commercial. And then on top of that, government agencies, both military and civil agencies, and all, basically every country has a meteorology agency, and very few of them have ever been able to fly their own space programs. It's really just the US, the Chinese, the Russians, the EU. There's really just 4 or 5 groups globally that have actually been able to fly their own weather satellites. And for a lot of countries, it really is a pure civil service. There's not a big sort of commercial industry. So the traditional weather industry is sort of commercial picks up from government data and models and then tries to do that last mile delivery for different use cases. So because of that sheer sort of scale of opportunity, we also recognize very easy to dilute yourself too much, trying to be all things to all people. So there's a handful of cases where we're working directly with insurance and energy companies and ag companies and so forth to build some very specific things. But most of the cases we're looking at are working more with channel partners who are addressing end user needs in different markets already, and we can help augment their existing products and services with new data. We're civil servants trapped in a startup. We saw this mission need, and government agencies are doing their best. Honestly, give them a lot of credit for, there wouldn't really be any weather infrastructure without government investment, right? So it's not a 0 to 1 thing. We're just trying to help fill in gaps and help in a way where a startup can sort of navigate more sort of nimbly than an agency might be able to. And just ultimately about helping people. But really, it's the funnest part for us is working with different users. Every week I'm getting to dive deep into some new thing and learn all about a new industry or new use case. And it's a lot of fun. That's what's really driving us, is just the learning opportunities that we're being afforded from this mission.
We'll be right back.
This September 18th and 19th in Denver, a tight community of leading experts is gathering to tackle the toughest cybersecurity challenges we face. It's happening at MWise, the unique conference built by practitioners for practitioners. Brought to you by Mandiant, now part of Google Cloud, MWise features one-to-one access with industry experts and fresh insights into the topics that matter most right now to frontline practitioners. Register early and save at mwise.io/cyberwire. That's mwise.io/cyberwire.
Welcome back. While many of us back in May were enjoying the aurora light show from unusually strong solar storms, we did note at the time that turbulent space weather can also cause problems for satellites and the industries that depend on them. Along with all of the stunning pictures from the mid-May auroras, there was news that many farmers who depend on geolocation technology were delayed from doing their spring crop planting because of GPS service disruptions. And now we know exactly how big that disruption was. Kansas state economist Terry Griffin says U.S. farmers may have lost up to $500 million in profit due to the planting delay from the half-day GPS outage from this year's geomagnetic storm. $500 million. That is quite a number. So how is that kind of impact possible? Well, timing is everything when we're talking about crop planting. And the timing of that geomagnetic storm in mid-May for the Northern Hemisphere was really not great. It was smack dab in the middle of a planting season that was already running late due to regular old weather, lots of rain this spring. And while the actual GPS outage was only a few hours, that was enough of a knock-on effect during the busy planting season, especially when you're talking about farmers planting big cash crops like soybeans or corn in tremendous volumes. Half a day's loss of planting can significantly hurt crop yields down the line, because the later you plant, the lower the yield. It'd be nice if these solar storms picked a more convenient time to happen, wouldn't it? Still, it's quite a data point there. $500 million in lost agricultural earnings for farmers. Certainly something to remember next time someone asks why space weather matters. That's it for T-Minus for June 21st, 2024. Brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in this rapidly changing space industry. If you like the show, please share a rating and a short review in your podcast app. Also, please fill out the survey in the show notes or send us an email to space@n2k.com. We're privileged that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K makes it easy for companies to optimize your biggest investment, your people. We make you smarter about your teams while making your teams smarter. Learn how at n2k.com. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazes. Thanks for listening, everybody. Have a wonderful weekend.
T-minus.
Attention all security professionals. Want real-time IP intelligence at your fingertips? Sign up for Scout Insight's free trial today. Get immediate insights into threats, search any IP with no training required, and enjoy intuitive graphical results. Whether you need to identify compromised hosts or enrich Splunk queries, Scout Insight has you covered. Don't wait. Accelerate your threat response now. Visit teamcumry.com/cyberwire to start your free trial.